Well, greetings everybody. So this video will be a continuation of one I just made where I went through the 3 scenarios of hypothesis testing with my own notes, okay? And so I want to continue that with this problem in MyMathLab, where here we have an actual study with data and we're going to extract what the hypotheses are, perform the test, and decide which one we think is true. Okay, so let's read through it real quick and then I'll show you my summary of what's presented in the problem. It says a random sample of 77 8th grade student scores on a national math test has a mean score of 274. The test result prompts a state school administrator to declare that the mean score for the state's 8th graders on this exam is more than 270. So he thinks that because in this one sample their mean was 274, that it maybe previously they believed for the population that the score was 270 on average, and now he thinks it's more than that just because of the sample. Okay. Assume that the population has a standard deviation of 32 and at alpha is 0.03. Is there enough evidence to support the administrator's claim that the true mean score for the population of 8th graders is more than 270? Okay, so here's my summary of what we're given there, because always when we have our question involves a lot of reading like that, I think it's good to have a summary of, well, here's what I was told, and I kind of separate it all out, and then I'll assimilate it back together as I work it. So we had a sample of 77 students and the average score on that test was 274. There's the population of all students, and I know that the standard deviation is 32. It doesn't say anything about what the mean is, really. Like, you know, it doesn't say, by the way, the mean score is whatever for the entire population. Because remember, the sample comes from the population in order to study it. Doesn't say, but it's okay. We don't really need it to be explicitly told to us, so that's fine. The test significance is 0.03. And then the claim that was made is that the population mean is more than 270. So when I see this right here, declare that the mean score for the state's 8th graders on the exam is more than 270. They're referring to the population, mu, and to express that as inequality, we say mu is greater than 270. Now, when in any hypothesis testing scenario, we have a null hypothesis, which is H subscript 0. Sometimes we call this H naught. And then there's the alternative hypothesis, H subscript A. H naught will always involve the equal sign, and these two will together represent all possibilities. One of them will be explicitly given in the question somehow. So when this was explicitly given in the question that, by the way, we think the population mean is more than 270, then the alternate hypothesis was given, okay, in that statement. Now, what's true if mu is not more than 270? Okay, when I say that these represent all possibilities, like what's left? Well, that would be mu to be 270 or less, and together this makes up like the whole continuum of numbers. All right, so this one I was given, and this is what would be the case if this one's not true. Okay, so this number more than 270, well, if that's not the case, then that means it's 270 or less. Okay, so mu less than or equal to 270. The null hypothesis, H naught, always represents an equals in somehow. It either has an equals in it, or it's got less than or equal to, or greater than or equal to. That's what makes this one the null hypothesis. So first part is answering that properly. Okay, so here's the null in the alternate hypothesis. The alternate hypothesis happened to be the claim in the question. Okay, now the procedure for hypothesis testing from this point goes like this. First, we compute this thing called the standardized test statistic, okay? And that is x bar, which is the sample mean, minus mu, which is the population mean, which will be implied in this. See how this says mu is less than or equal to 270? So, okay, we take it that we can say that mu is 270, all right? So mu is 270, population mean, root n, where n's the sample size. Okay, so 77 over the population standard deviation, which is 32. So I do all the math on that with my calculator, and I get 1.0969, so on. I notice in MyMathLab it says to round to 2 decimal places, so if I have 1.09, then that's going to be 1.1. All right. Now, from there, here's what we do. I go to the standard normal curve, and that's the normal curve with a mean of 0 and a standard deviation of 1. And this is a right-tailed test. Okay, so why is it a right-tailed test? Well, it's always true that if your null hypothesis H0 is expressed as H0 less than or equal to a number, that Z will turn out to be positive in you're conducting a right-tailed test. Okay. Otherwise, you have a left-tailed test if H0 was greater than or equal to a number, and if H0 was expressed as just equals, it would be a two-tailed test. Okay. Anyway, so I have a right-tailed test here, and I take my standardized test statistic. Okay. 1.1, and it's going to be somewhere over here because the mean on the standard normal is 0. That's where the peak is. And I calculate the area to the right of that number, which StatCrunch makes that easy to do. Okay, so I calculate the area right of the standardized test statistic, 1.1. That will be P, the P value. And then ultimately, I'll reject H0 if P is less than or equal to alpha. Well, let's do that. Since we need to find this area, we need to find this number, the area on the standard normal curve, right, of 1.1. Go ahead and do that. Okay, so I got StatCrunch open, and I go to calculators, and I want the normal, and by default, it opens the standard normal, the one with mean 0, standard deviation 1. And I need to find the area to the right of 1.1. Alright, and the way I do that is if I want area to the right, I put x greater than, and then I want a 1.1, and if I put compute, this number will be the area on my graph. So I drew a picture kind of like this over in my notes over here, and it says 0.1356. Okay, so let's do 0.136 or so. So that's going to be 0.136. Okay, that's how big that is. Now, in MyMathLab, here it said round to 3 decimal places, so I give you that number to 3 decimal places, 0.136. Okay, so what's our judgment? Alpha 0.03. Okay, all right. And here I'm getting 0.136, right? Okay. All right, so in that case, I'm not going to reject, whoops, hold on. I'm not going to reject the null hypothesis. I would reject the null hypothesis if P, which I found out to be 0.136, okay, was less than alpha, which is 0.03. But 0.1 is not less than 0.03, much less 0.136 is not less than 0.03. So I do not reject. Okay, so do not reject. So what's another way of saying that? Is that I accept the null hypothesis as being the true statement. Alright? So I think that this one, the null hypothesis, that now the mean score really is 270 or less. Okay, this is the one that I'm going to accept as true. Okay, so you could say it like that: I accept the null hypothesis as true, or I reject the alternate hypothesis. And that'd be like I reject the claim that was made by the school administrator based on this sample. All right. Okay, so let's see how MyMathLab phrases that last part. You see how it says interpret your decision? 3% significance, so that significance level of 0.03 means 3%. There's not enough evidence to support the administrator's claim. that the mean score for the state's 8th graders on the test is more than 270. Yeah, I mean, this is the one I'm going to accept as true, and I don't accept that one as true. Okay, that's just another way of saying that. Okay, so that's how we go through the procedure of hypothesis testing. It'll take a careful reading of the question to see what, you know, somehow, some way you'll be given either the null or the alternate hypothesis. Null always has an equals in it somehow, okay, but together they represent all possibilities. But then the procedure from there will be more or less standard. It might vary a little bit if you have a left-tailed, a right-tailed, or a two-tailed test. I'll make another video with an example on a two-tailed test, but we still calculate this number p, we judge if it's less than or equal to alpha, and then decide to reject or accept the null hypothesis.